Everyone, this is Mike for Faraday Research. I haven't done a video in a while, other than my shorts I've been putting out there on some of the projects that I've been working on. And I've decided I wanted to do some serious testing on the Adams motor generator to kind of prove my point, because people out there just seem that they don't get it. So I want to be very clear in this next video. I'm going to do two little segments here. The first segment, as you can see, I got my scope. All right, it's not running right now. It's basically just picking up residual energy that's from the last test. Actually, maybe I'll just shut it off. And I'll turn it back on. So I'm going to do two tests. Now, I've been talking about the piezoelectrics, okay, and how important they are and how much of a game changer they really truly are to the Adams motor, or any pulse motor at that. And people have to understand what is actually happening, and I think I'm starting to figure out what is exactly happening when the piezos are running in the Adams motor. As you can see, I got 4 of them lined up in series. Okay, they also have these high voltage neon lamps. It takes 90 volts to get those going. I got 4 of them running. Okay, now I also have 40 watts of LED bulbs. I know this isn't the best load. I should be using a resistor, yada yada. I get it. I understand that. What's even more important is what's making this motor do what it's doing. Okay? The first test, what I've done is I've actually disconnected the piezoelectrics from the system. Okay? What you'll notice right away, I won't be able to light up hardly any of the lights. I'll only be able to get one light going. That's it. Nothing else. And the voltage I'll be doing on this test, I'll be running at 18.6 volts. Okay, I want to get it up in a higher potential just for the demo, just to kind of get my point across. Nothing different. Got my coil hooked up with my proximity sensor from a 3D printer. I'm using that as the trigger switch. Nothing fancy, nothing crazy. But when I made the discovery with the piezoelectrics, I didn't realize the actual potential of what they are actually doing. Are they actually doing anything at all? Are they doing anything? And from my test, they absolutely are doing something, and they are doing something that no other pulse motor out there is doing. So before, I was running a pulse motor, no piezos, running, trying different coil sizes, trying capacitors, and all that. Probably one of the worst things you can do in this system is add a capacitor, believe it or not. As soon as you add a capacitor to the circuit, it kills your top end voltage. And the top end voltage is what's getting trapped inside the coil. All right? Jim Murray, he's been studying this for years and understood that there is voltage or power being generated in here, but it's not getting pushed out. There's a difference between back EMF and capacitive inductance. So what's happening is this is actually turning into a capacitor. So what does a capacitor do? It holds power. All right? So what Jim Murray's been talking about for ages, and even Paul Babcock's been talking about this too, is that trapped energy in the coil has to get out, but there is no means of it getting out. So I found, well, what they were doing, they're using advanced switching technology to do this. I'm using a different approach. I'm using the piezoelectrics. And what the piezoelectrics is doing is getting that trapped voltage in that coil capacitor, because the more wire you have, the more capacitance you have in a coil. You have to get that power out of the coil. So my discovery, I guess it would be about a year ago, when I hooked up my first piezoelectric to the circuit, to my astonishment, I was able to get a lot more power output, because up to this point, I was only able to light up one LED bulb with this system. And I could be putting 18, I could be putting 24, I could put in whatever I want. I could not get any more power out because all the power is getting stuck inside the coil. I couldn't get out. So back EMF usually happens on the bottom part of the wave. I'll show you here. So you got your typical, because we're pulsing DC, it's a modified AC. It's, you know, you call it the cheap man's AC. So you got the up and down motion. All right. So what we're after is getting a transient spike on the bottom end. But my piezos is giving a different effect. Something I've never seen before, ever. Not even on YouTube or nothing. Nobody talks about it. I've seen it nowhere. I'm getting transient negative spikes on the high end. Not just on the low end. I'm getting it on the full spectrum of the wave. Up and down, up and down, up and down. So I got my probe set at 10 times at 100. All right. So it's not so much what my numbers are here. They are pretty accurate. Let's see. I was getting, from peak to peak, 240 volts, 237 volts average, maximum 244, minimum 221, and then 2.06 RMS. Okay. This is what I was reading before I started. So we're going to fire it up. And what's going to happen is the first test is not going to have any piezos hooked up. It's just going to be a regular DC waveform. So I've got the probe hooked up right where the lights are. Now I do have one very small capacitor. It's a tiny little, I think it's only 20 picofarad ceramic capacitor, which can handle about 15 kVA. Because I'm pulsing DC into it, so it's going to act like an AC type current. So let me get it fired up, and you can see how the waveform is going to be running in this. It's running at 18 volts at about 40 milliamps. Now you're going to notice right away, I only got the one bulb going. I can't get any more bulbs going. Like, I can put them on, and that's it. I can't get any more voltage out. All the power is being stuck inside the coil and generating these EMF spikes. Okay, so see, now I'm getting those transient back EMF spikes. Okay. And some of them are even showing up here, even on this model, which is, I'm finding kind of weird too. Because my motor never performed like this before. I would get usually the transient spikes at the bottom, not on the top. So this Adams motor is doing something. It might have to do with the actual mechanical switch. Alright, so you can see where these transient spikes are coming up. But I could barely light up one 5.5 watt light bulb. See, even with all the capacitance inside the coil, it's unable to get this thing going. Now, my theory is probably the piezos are somehow modulating the power inside and releasing higher currents. So, to get these neon bulbs going, they need 90 volts. I've got 4 of them hooked up. Alright? So, when I do the next segment, you'll see that I'll have these running, the piezos will be running, I'll be able to light up almost all the lights on the thing, and I'm not adding any more power to the system. I'm just hooking up these guys. So I'm going to prove to you right now that the piezos are the game changer when it comes to a pulse motor, hands down. Alright? So I'm going to hit the auto reset on this. And now you can see the transient spikes where they're happening. Some are happening up here, but most of them are happening on the bottom. So my peak-to-peak current voltage is hitting about 360, 370. Frequency is going up and down like crazy. It's going between 60 hertz and as high as I've seen like around 200. RMS hertz is about 339 hertz. I'm averaging about 56 hertz per minute. Maximum 16.67 kilohertz a minute. Duty cycles about around the 40%. 45 average. So you can kind of see the numbers here. But the waveform is very unique. I've never seen transient spikes like this before. Now, it's going to be more evident when you see the amount of power that I can get out of the system the second to hook up the piezos. So, bear with me for the second segment, and I'll show you the next setup. Okay, everybody, we're back. We're doing the next segment here of the test of the Adams motor. Okay, so I'm getting things fired up. Let's get this motor tuned. Let's get it going here. Get the coil in position. Okay, so now you can see the neon bulbs are lit. Alright, look at the bulb now. Alright, look at this. I couldn't do this before without the piezos. Look, I'm lighting them all up. All that energy that was stored in the motor coil is now coming out. Like I could keep going if I want to. Alright. So you can hear the piezos. And if you hold on to them, you can get quite a little jolt. So these are lit up, like just to show you. They are lit up. They take 90 volts each to run those neon bulbs. Now, look at the lights. I couldn't do this before without those piezos. That's all I've changed. Okay? So I'm going to adjust the current on this. It's at 60 milliamps. At 16 volts. I'll put it down to, let's put it at 50 milliamps. Let's keep between 40 and 50. Look, all my lights are lit up. I could not do that without the piezos. All the power is being stopped inside that coil. It's trapped. So the piezos is doing something to get that voltage out. I don't think they're generating power. I think they're insisting in giving the coil something to do with the frequency to push or up the voltage in some way to push that power out, get it out, create a current. Without current, it's trapped in there because when you got a huge coil, it's like a capacitor. It's trapping the power. Now, look at my waveform here. It's going crazy. So my peak to peak right now is hitting about almost 400 volts. My max voltage peak was 510. Frequency is about 60 to 100. Yeah, I'm averaging about 127 hertz. So I'm running at a higher frequency. So it's increased the frequency. So if I disconnect the piezos again, I couldn't run these lights at all. I could only get one barely lit up. So there's your proof. Like, anyways, yeah, if you haven't subscribed to the bottom right hand corner, give me a thumbs up if you like the video. Now you can kind of see what's happening on the scope. Let's see if I can get this a little bit more visible. It's kind of hard to see in the dark here, but you get the idea. see if I can get into the menu. So I'm slowing down the frame rate, but you can see these massive negative spikes. But they're also occurring at the top. So it's something to do with the piezo's, with the frequency and whatever it's doing. It's adding extra voltage at the peak in order to give it current to push the power out. Because there's no other way to describe why, without the piezos, I can barely get one light lit up. And then when I put the 4 piezos on, now I can get, about 20 watts worth of lights lit up. So, I don't know, correct me if I'm wrong, but, I'm 100% positive that the piezos are doing something to increase the current coming out of the coil. It's assisting on pulling the current out of the coil and into the circuit to get the lights running. So, yeah, I don't know what else I could tell you. So, right now you can kind of see the waveform I'm getting. Let's see, let's change this here. Let's put this set it at a better 100. Now you can actually see the waveform I'm getting. I'll try to stop it here at a good spot. See? I'm getting the transient spikes where they actually shouldn't be. They should be down here. So I'm getting transient spikes all through the whole spectrum. They're happening at the bottom, they're happening at the top. See? I got a transient spike right there, right at the bottom of the waveform. I'm also getting them up here, I'm getting them here, I'm getting them here, I'm getting them all over the place. So I don't know if that's at all assisting my my power output. So it's really bizarre. I've never really seen a waveform quite like that. And it seems to be really working for me because without the piezos, it's not happening. You can't get the power out of an Adams motor. Not only that, before I end the video, I'm going to show you, I'm running at 16 volts at 50 milliamps. So a bigger coil helps. It stores more power. Use the piezos to push that power out of the coil, but it's taking jack to run it. Like 50 milliamps is nothing. That's why I was able to use my 500 farad super cap and run this for 4 hours. Because you could have voltage, higher voltage to make it run faster, get your higher output, but it doesn't require any current. You don't need the current. I've got this thing as low as 2 volts, and it's still moving because it requires no current to run this motor. And I think that's kind of the basis of what Newman was after. You don't need current to run a motor. You just need voltage, a big coil to harness that power inside the coil, and then push it out. This is just a different way of actually doing it. Leave your comments below. If you haven't subscribed, bottom right hand corner. Also got my Patreon, my PayPal. If you like what I'm doing, help support me so I can afford to get equipment like this that was donated so graciously by a good friend in the US. Sent me that, and tons of other stuff that I've gotten from Patreons and my supporters, and they've just been helping me out over the last couple of years, and greatly appreciated. So let me know what you think, and we'll see everybody soon.